Hey, this is the second episode of Python 101. Today we're going to talk about data types. So, what is a data type? Well, the name denotes the meaning. A data type is a type of data. Allow me to elaborate. Typically, when I think of types, it's in the context of relationships.
Hey man, what's your type?
Type? I don't know, man. When you're checking someone out, you typically consider two key factors, those being looks and personality. I'm just gonna let that sink in. We'll look at data types in the same way. You can think of looks as the way that the data is represented. When in doubt, ask yourself, what characteristics define this type of data? And a more formal name for this is an attribute. A better word for personality is functionality, and it refers to how the data behaves. In what ways can we interact with the data? It's okay if you don't fully understand this right now, because you don't need to in order to move on to the next part of this lesson, which is primitive data types. Primitives are the most basic forms of data that you can represent in Python. There are 4 primitive types, and for now I'll be checking them out solely based on their looks, because you might say that my taste is rather primitive. So what characteristics define each of these data types? Int, or integer, is a whole number. It can be positive or negative. Floats are decimal numbers. A float must have a decimal point, and it can also be positive or negative. str, or strings, are strings of characters enclosed by quotations. Note that you can use either single quotes or double quotes, but the one that you use to open the string has to match the one that you use to close the string. Bool, or booleans, are either true or false. Lastly, you can use the type function to find the type of an object. I won't explain this in depth in this video, but you can experiment with it on your own in the Python console. Okay, now it's time for some practice. If you can answer all of these confidently, you're ready to move on. I would recommend pausing the video here and taking some time to ponder over these. Alright, I'll assume that you've done so, and now let's go over them. First, we have true. Now, this is simple. This is a boolean. Next up, 128. Since this is a whole number, it is an int, or integer. 6.02 is a decimal number and is therefore a float. 7.9, although it is a decimal number, is enclosed in quotation marks and is therefore a string. -0 is equivalent to 0, and this is an int. Next up, str. Though this appears to be a valid string at first, you might recognize that the closing quotes are different from the opening quotes, and therefore this string never ends at all. This actually ends up as an error. 49 enclosed in parentheses is just 49, and is therefore an int. Parentheses in Python can be used the same way as they can be in math. Alright, next up we have hello plus world. The addition operator is something we haven't seen before, but it's reasonable to assume that a string added to a string results in yet another string. And indeed, this expression turns out to be a string. Next, we have false. Now I got a question for you. Is this a boolean? Now the answer is false. Trick question. This is not a boolean because booleans in Python are capitalized. And if I were to pass this into the type function, Python wouldn't be able to recognize this as a boolean because the f is lowercase. Next, we have my wife left me for her boyfriend. Again, trick question. While you might be tempted to call this a boolean since the statement is true, in actuality, this is a string. Note that I have single quotes inside of the string. This is okay in Python, as long as the type of quote used in the string is different from the quotes used to define the string. Typically, you would want to do something like this in order to imply that the statement inside of the quotation marks was not said by you, when in reality it